Good morning, good afternoon, everybody. Thanks so much for joining this next episode of In a Nick of Time. We're gonna get started in about 5 minutes with a great, amazing guest, Phil Straw from SoftIron. He's gonna talk about sovereign clouds and data-centric security. There's gonna be a great deep dive on kind of the things to pay attention to when you think about sovereign clouds, but also is it feasible to build one and keep up with the pace of relevance and the baked-in security? So stay tuned for another 5 minutes. We're going to get started. Good morning, good afternoon, everybody. Thanks so much for joining this next episode of In Any Cup Time. We're very lucky today. We have Phil Straw, the CEO of SoftIron, talking to us today about sovereign clouds and data-centric security. It's a top topic asked by the audience to really deep dive into not only what data-centric security actually means, but also whether or not it is feasible for anyone to create a sovereign cloud and also keep up with the pace of relevance, which obviously would defeat the point if you end up being 20 years behind everybody else, but you are very secure. You can also decide to turn off your laptop and hope for the best and see what sticks, but that's not going to work too well. So, with that, today we're going to be doing this deep dive with Phil, and you'll see he has such a impressive background on the topic. So, it's going to be a great discussion. If you've yet to subscribe to the show, please do that. Go in the nick of time .tv and subscribe to the mailing list. You're going to get a one email a week to tell you about the next episode. And you'll see we're going to be moving to a 2 week schedule. Now we have a lot of guests planned until September. So a lot of activity going on. And so we're going to bring top guests throughout the rest of the year. It's going to be a lot of fun. So subscribe at nickofTime.tv and get the email to be notified for the next episode. With that, I want to remind everybody, if you've not yet giving it a shot, go on AskSage.ai, create an account for free, and go try out what we built to bring GPT to government teams and financial sector, and now soon healthcare organizations with HIPAA compliance. We just also launched a NATO enclave for our European friends. So we have a region in France with Microsoft, Azure, OpenAI, and of course one here in the US as well, where all the data is protected and fully compliant with the NIST cybersecurity framework for CUI Impact Level 5. So go check that out and check out the plugins, the agents we built, and all the integrations with APIs and real-time querying that we've built to bring GPT to you guys in a safe and secure manner to protect your IP and protect your data. So check it out, AskSage.ai. And if you use the coupon code Let'sBeatChina, you get Sage for $25 a month. So forever. It's a pretty good deal. It's only limited to another probably 500 users. So running out of seats there. With that, wanted to give you a quick rundown of Phil Straw background. Of course, he's a top expert in IT infrastructure with national security implications. He was born in the UK and has a degree in computer science, but really you'll see his wealth of knowledge comes from different topics, from sovereign clouds, cloud technologies, of course, and the future of IT, where national security matters, which obviously for us is essential. You'll see how we will be talking about today all the implications with 5i and G7 and so on when it comes to the concept of sovereign clouds. Um, Phil was the co-founder of SoftIron, technical visionary there. Initially started as a CTO and moved to the CEO role. He has a deep background in designing high performance, low power, ultra dependable appliances for military special operations. He spearheaded SoftIron, that a company that's re-engineering what is possible when it comes to performance, density, and efficiency in modern data infrastructures, which is obviously so important to the mission. Before that, he served as a CEO of ADX Technologies. He co-founded and was a CTO of .fx, the VP of engineering of Securify, and he worked both in technical and product roles at Cisco and 3Com, and he's been now living in California for the past 20 plus years. With that, let's bring Phil on the show. Welcome. Good to have you.
Yeah, thanks for having me.
Yeah, very excited to have an expert like you that really understand kind of the balance, right, between innovation, security, compliance, and how to do that in what people love to call sovereign clouds, and what data-centric security even means in that kind of universe. So before we get started, we love to get a little bit of your journey. That's always where we get started. So over to you for that.
Yeah, I mean, for me, I guess I got started as a child. I was sort of addicted to computers, and I think I might have been the first child to ever have restricted screen time. My parents were paranoid about that. So it left me with a thirst for technology, and I've been fascinated with it ever since. And then, like you mentioned, about 25 years ago, I came to Silicon Valley for a year, and I'm still here. The bright lights keep me going. And then I've just been doing startup after startup since then. Usually in a sort of technological capacity, CTO, something like that. And then, kind of scattered across lots of industries, on purpose, from pure software to scuba diving and special forces, electronics, aviation, intelligence community, automotive, that kind of stuff. So really broad spectrum of technology, but the big theme that really is pervasive throughout my whole time in technology is just networking products, and computer security really is the big thread that runs through everything.
Yeah, no doubt. You've been busy. And when you look at effectively what led you right to this field of data infrastructure and cloud technology, what was kind of the the beginning of that? I know cloud is, and data infrastructure is kind of this vague thing that evolved, in the last, 40 years. But what was kind of the trigger that led you to it?
Maybe the answer is to make it less vague. So we started
Right.
SoftIron about 10 years ago, and my co-founder and I had this persistent water cooler conversation, you might say, about how amazing public cloud is, and was back then, and it was it'd been emerged for half a decade, and we were fascinated that the industry in general didn't see uh, didn't really see a path to replicating a public cloud experience of consumption. You swipe a credit card, you get an outcome, and then burying all of that infrastructure in a consistent way so you could do it on premise or in a colo or in a hybrid sense. And as we kept watching and kept discussing, we got increasingly frustrated. And then we started to talk about properties that would come from that, like freedom from vendor lock-in, elasticity, security, power efficiency even, and you kind of really understanding what the machinery is and what it's doing when you run it, as a private or hybrid cloud. And so it led us to this incredibly holistic, really radical way of looking at things that as we unraveled this problem, it became more and more holistic, and it sort of led to the business that we've got today. So that's sort of the path, really.
Yeah, it's interesting, right? Because obviously vendor lock-in is really something I've been preaching, at least avoiding it for many years. And you look at also the benefit of having a comprehensive and a holistic security stack that's agnostic to the CSP, the cloud provider, and being able to have the same visibility and enforcement points throughout an organization. I would argue that's the foundation of good cyber practice, right?
Yeah, I mean, it's an interesting time because public cloud is an amazing thing. You can see that people want to consume infrastructure rather than deal with it and run it and have the hassles of really doing that. Particularly without hyperscale, you'd argue very, very difficult to do as a set of people trying to thread the needle through all the different technologies. And then there are, each individual public cloud has this, it seems almost devilishly devised set of APIs that once you code to them, you are really welded into that reality. It's not very portable. And, there are things that are being done in industry that will mitigate that. But I think it's just a phenomenon of the fact that each public cloud vendor has the proprietary view of how they'd like the world to run. They obviously are at hyperscale doing it for real and making it look good, which they do. But that leads to some natural consequences. And so I often say this, that when public cloud is good for you, it's probably perfect, but be careful. And if you really want to have freedom, you kind of almost have to start with a hybrid approach or a sovereign approach first, you might say, where you kind of run to that first, and then you use public cloud like a utility when it's best for being public cloud. When it's good
Yeah,
for
you,
you.
you should be using the best tool for the job, right? And you should have diversity of options, and you should not be locked in such a way that prevents you from trying new things. At the
Right.
same time, you want to have the same cybersecurity stack, so you're not stuck in time, and you're not creating massive shadow IT and kind of cyber gaps throughout the organization. So
Yeah.
so I guess when you look at the state of industry today, what's your take on that?
I'm always schizophrenic about the state of an industry, and like technology is no different for me. I think technology moves so fast that we lose more tools and technologies behind us in the name of progress than most industries create, right? So it's at least from the outside, it moves incredibly quickly, especially if you look at speeds and feeds and capabilities. It's kind of staggering, amazing. And then as a technology creator inside an industry doing stuff, that can be so slow and painful and hard. Particularly, I'm talking about this 10-year journey we've gone through to make SoftIron. But one thing's for sure, whether or not you think it's moving fast or slow or whatever state you believe it's in, it's definitely moving. It's definitely doing, I think, for the most part, great things. But we're also dealing with increasing complexity. And, as you know, Nick, there are lots of things in tension with complexity. Like one is security. It's inversely proportional and they're not friends. So that can be an issue, along with a lot of other things. But I see the industry in the cloud context, particularly sovereign cloud, doing a number of things. I mean, we're jamming things together that are maybe faster or prettier than they were 20 years ago, but they're fundamentally the same thing. They're servers, they have a boot drive, they have whatever. Things get better incrementally, but they're basically the same thing. And we're creating clouds by assembling things together. And sometimes we do that in a reference design where we take a bit of this and a bit of that and we plug it together and hopefully it works because it's a well-tested reference design. But it often doesn't come on a customer's term, on their turf, doing the right things exactly for them because it's a fixed design. And then the industry is also doing cloud as a service, which is more of a business model, I would say, than an arrangement of things where someone does that cloud service for you on-prem or in a sovereign sense. And then we see the public clouds doing some limited things on-prem, which to me can be a beachhead against choice or sovereignty anyhow. But I think really in the sort of case for what we're doing and spent the last 10 years doing is we need to solve this problem as an industry technologically. It needs to be done holistically. We need to approach, okay, we're really going to build a cloud and we're not going to go back in time 20 years, find some parts, assemble them, and then see what best result we can get. Because there are so many properties, secondary properties of infrastructure in general, be it networking properties, storage, compute, virtualization choices, APIs. If you're going to get to a security result or build a sovereign cloud that you really care about, that's a lot of lift. And so classically, you can get someone to do that as a service. That's fragile, human error prone, etc. Or you can do it as a technology and as a product that is repeatable. And you invest in doing that as a productization with a capital P. And if you do that, at least you stand a chance, right? That's sort of my approach to where I see the industry today. And you see people all basically drifting in that direction. That is going to have to be the outcome because the reality is the reality, right? And the properties are the properties. So it's pretty simple to see where it's going to go.
Yeah, and people are not waiting for us to wake up and realize it, right? And so the velocity and the pace of industry is increasing drastically, and often people have a tough time to reinvent themselves, to learn and to keep up with what's happening, and we're getting pushed, to be more and more efficient, right? And you see that, of course, with all the new fancy AI technology coming out. But when you look at zero trust, right, and all the principle of a modern cyber architecture, you see this move, right, to what people call data-centric security. First, let's define it for the audience, and then tell us a little bit about why does it matter.
So yeah, I mean, data-centric security basically, it takes an approach that focuses really on data and the resilience of data and various other properties. And I mean, data's everything. You just have to look at the hyperscalers to see that data's everything to the business. And you can see it, it's like almost proof in absurdum, right? In that the hyperscalers are so big. And what do? They take data in almost every case and they weaponize it or use it as a weapon of war in making the business monetized. It's precious and they guard it fiercely. they may be the ultimate example of data-centric security guys. But I see data-centric security as one lens of many. And I believe when you talk about security, it's important to focus not just on a lens or a technique or a tool, but also a real security outcome. And often we see process and mitigation, which are very important, but they're not an answer alone. So I believe in a depth of methods, or a protection in depth of methods. And that comprehensive approach, I'd say, is really, really important. So not to dilute just to focus on data, but I think it goes beyond that. But you asked sort of what are the key challenges, and I think for me, comprehensive approach is one around data-centric security. You obviously have robustness challenges with data, so data protection strategies. When you get rid of data or you destroy it purposefully, then you want to know it's really destroyed. Often there are multiple copies of things or different schemes for data protection that lead you to that. There is, mobility of data and inherent costs of doing that in a public domain. Recovery of data when you want to get data back, and then is it mutable or immutable for obvious security outcomes. And then, to me, one of the things I think is often missed about data-centric security or data in general, as it relates to security, is how do you consume it? And one of the things that, I think is a challenge with sovereignty or security is trying to train the user and trying to mitigate things that can be uniformly buried in places that can be naturally consumed. You might say through a keyhole that's completely consistent, completely repeatable, and guess what? You can productize it. And so, whether or not you're consuming block storage, object storage, file storage, how do you do those in canonical ways? And then how do you embrace cloud and keep scale, be able to incrementally approach scaling, treat all of the items, be it hardware or software, as consumable, and then, get to a continuous amount of scale with performance, with all those consistent security properties. And so the data-centric approach to me, I think, is the thing that everyone should be obsessed with anyhow, because the data is really the crown jewels these days.
Yeah, so people would argue that we've been trying to protect data forever, right? But yet there's this term, data-centric security. I guess we kind of moved from a perimeter defense around the castle to what? To something that's protecting the data down to the cell, to the field level. I know, in the DoD we were trying to embrace data centricity so that each field of a data set could potentially be labeled down to the cell, and you could have something that would be secret, top secret, or whatever, and so you that would enable sharing in a more granular fashion down to the field level. Do you see kind of the challenges around becoming kind of a proxy to data set and policy enforcement points and all the innovation being done from all these data centric security products? Is that part of the puzzle here?
I think it really just harkens back to protection in depth. And one of the phrases that's not mine that I've heard about data-centric security, which I thought was genius, is, you mentioned perimeter defense, you mentioned certain techniques or focuses with security. And someone once said to me that the great thing about data-centric security is data's everywhere. And so you're, by implication, doing security everywhere, which I thought was genius. I think that's probably the best description I've ever heard of it at an elevator level, an elevator pitch level. And I think it's correct. I think, there's tools and techniques that are appropriate. I think everywhere that data lives, people should be obsessed with that data and data security. I kind of have done it for the last 10 years. It's an embodiment. And I think getting that right is incredibly important. So if it needs to be on a field by field basis, with metadata and the ability to really control and audit that, I think that can be appropriate. And then I think, like everything in security, most things end up being a business decision. And at some point you do the minimum viable thing that gets you the absolutely correct security minimum. And I think that approach also is a very good, the data-centric security approach to IT in general leads you to a very good framework for making those decisions well. And so it's hard to be absolutist in a world that's commercial. And so making those decisions often, be it in government, be it in a corporation, or even in a public cloud for that matter, I think that approach leads itself very well to what is the price of this asset? What is the cost of losing it? What is the business pros and cons, where you can really truly assess the pros and the cons and the value and the downside of each piece of data that you look at. And different data has different dispositions, has different life cycles, it gets consumed differently, and it has different value, different threat value too. So to me, it's just a great lens. It's another tool.
Yeah, I guess, when you look at the scale now and how bloated became, zero trust as a term,
Right.
I think data centricity is kind of facing the same problem in a sense, like you said, with the elevator pitch, right? Every data is everywhere, so it's everything. But then again, how do you define, right? Just like zero trust, we had a very well defined rule at first, and now it became this, bloated definition, which effectively now includes every cyber thing you could do on the planet. So it's really a synonym to cybersecurity nowadays. If you look at the great work of the DoD team from the Zero Trust strategy document that they issued with Randy, he's done a great job listing effectively what I would argue is not just Zero Trust, but really all of cyber. So we had a shorter definition, I guess, a more precise definition of Zero Trust. When you look at how to, if you let's say you audit two companies tomorrow, and the CEO asks you, hey, tell me if I'm doing data centricity security or not, what would be the top three things you look at? And if they don't do that, you're like, oh, you're not doing this. It's just you're just a buzzword. What are the things you would pay attention to?
I mean, in terms of data-centric security, I think for me, I would split that into two things: the sort of process side of the fence, then tools, techniques, technology side of the fence. And I think you have to do both. And I think we do this to ourselves as technologists. We overload these terms to the point that every term is almost meaningless after a decade. So, what does cloud even mean at this point? What does data storage mean? It can mean so many things to so many people. And I think that's why often it can be even more of a confusing playing ground. So when you talk about zero trust or data-centric security, there's just a continuum. Like you said, it's just so overloaded now that it's hard to say what that really will be definitively, unless you choose a position. And my position about data-centric security is the elevator pitch that I got from someone else, which is just approach data on its own terms, in its own place or disposition, for its own value or threat level, and have a comprehensive approach. And this is one of the things I think is not focused on a lot in data-centric security. Is you can often get wrapped up in the process side, or you can get wrapped up in the technology side. And I've seen in my career that people tend to have the bias generally. They believe the product will fix the problem: firewalls, intrusion detection, whatever the product is that embodies that security outcome for them. Or there's a process approach where you follow the process side of the house, and you do all the things, and you audit, and you do all goodness, right? But there's a partnership between those two things that gets you both an understanding of what you can see, but then a persistent effect that is embodied in doing something and getting the outcome that I talk about, as opposed to just the process. And so I think it's both of those things. And if I could say at a high level, what I'd say to a CIO is you have to have both of those things to really have a comprehensive approach to data-centric security. And then there's a checklist under each one, which we can go into if you like.
Yeah, I guess on the product side, what are the top three, I guess, checklist items, and the most important stuff that you would like stop immediately and be like, yeah, you're not cutting it.
Oh, I think things like access controls, the ability to do comprehensive productized audit, not just an audit process, encryption, understanding of enforcement mechanisms, and then also policies distinct from mechanisms. So that's what I'd say is the technology side of the house. And then and you asked about that, so that's that side.
And yeah, I mean, if you want to share a little bit about the process too.
Yeah, so I mean, I think the process side of the house is obviously it's embodied often in a productization, but The process side of the house is often more policy heavy than mechanism heavy. That's where the overlap exists between the two often. But I think just management of data security with tools and techniques is a process in itself. And then instrumentation and actually using that instrumentation, I think, is, the insight part of process, you might say, or monitoring. And then there's the ensuring that you've got authorization and protecting what data is key. How do you get access to these things? And then just also, I think a thing that's often missing from data-centric security on the process side is just the continuous discovery of data. And like, data is growing like no tomorrow, and things create data, and data creates more data with metadata, etc. And so data is exploding, and I think it's often really difficult for corporations or organizations in general to keep a purview on that. What data is being created where, and what is the value of it, what's the threat level of losing it or it being compromised, and then continuously doing that as a process, whether it's embodied in tools that do it or not. At some point it needs a human owner, and that's what I mean by the process side of the house.
That's very interesting, no doubt. So, we mentioned some of the key pieces now. You mentioned the process, you mentioned the product. When you look at the product side, you listed, access control and all these things. Obviously, you are going pretty fast throughout the list here. If you have to be a little bit more precise when it comes to, let's say, access control, right? People would argue, okay, are you doing role-based access control? Are you doing LBAC? What attribute-based access control? What are you doing to enforce, that access control throughout the organization? What would you say would be big enablers on the product side to achieve the access control of data, right? Which is obviously different from just like, hey, I'm a user, I have this role in a team, and I'm accessing this database now. Okay, but how precise do you have to be in terms of granularity of the controls?
Yeah, so I think that this is often an answer that, say, if you're a process person or a product person, the two P's in my world, you take a product belief of an outcome, that I can embody that in an outcome, then often the tendency is to pick one thing. And often with security, there are lots of considerations around the human domain, and just picking one thing is often not the right answer. Sometimes you need variable access controls, variable levels of authorization and authentication that lead to all sorts of issues around, do you use two-factor? Do you do role-based? How do you do it? And certainly the answer I would like to give is not ad hoc, but I think you can use different things for different kinds of data. And again, this is one of the things I think that's under-discussed in data-centric security, is that not all data is the same. And so everywhere there's data, you should be doing some kind of security thing, even if you decide that it's nothing, pretty much. But those choices, I think, are all business decisions, and to shoehorn one thing into the whole is not the right thing to do in most organizations. Sometimes it happens, but you don't often get the outcome that you desire. And so in our own organization, we have, data access controls that vary quite a lot. Some two-factor things, some role-based things, some things for source code, some things for intellectual property. We have separation of domains where certain people see some things and certain people see others. Some things are completely open, or mostly open, just to check that someone's an employee is really the only authorization. So I think the answer is it's variable, but I think there's two things that are really important whenever you say an answer in security is a spectrum of things, which is to do it with the two C words. So there are the two P words and there is the two C words, and one is consistency and one is comprehensive. So to do it in a comprehensive way where you don't just cherry pick key things, you really do the spectrum. And I think that's, in essence, the DNA of data-centric security. You get security everywhere data is, and that should be a method. And so doing it comprehensively. And then to me, I see everything as a cloud something at this point in my life. And one of the things about consistency is, one of the advantages that you can get from a cloud is that you can do things incredibly consistently. And that's a really key property when it comes to second order security effects. And so being able to embody how you do it, how it gets upgraded, make sure that there's, say, only one of that software providing a service to a cloud or an infrastructure is a beautiful property when it comes to consistency. And I think that that's one of the greatest tools that come from cloud. Not the only ones. Like, for example, you have in a real cloud, you would have tenancies above virtualization, but you also have separation using different kinds of virtualization technology. You can embody audit there, etc. So all of the process side of the house can be done nicely there too. So I think comprehensive is a big thing, and I think consistent is a big thing. And whenever I get to consistent these days, all I can see are clouds. Then maybe that's just my proprietary view.
Right. No, I think you're right. So, obviously we talk about the complexity of bringing all this stuff, right, across organization teams, but also platform in the sense of IoT devices, edge devices, mobile devices. We talk about multiple cloud, hybrid, public, on-premise. So how do we make this work? Do you see the answer? If you look at some people, for example, when they talk about, hey, I'm going to build a hybrid cloud, I'm going to have Amazon Azure and Oracle, whatever, right? They're going to have often 3 cyber stacks completely native to the cloud providers, with completely different products among the 3 clouds. I'm not a big fan of this. They argue that it's more seamless because it's cloud native and it's baked into the cloud provider. But I would argue you lose visibility, you lose kind of the holistic overview of what's going on across the enterprise, across the clouds. What's your take when it comes to making data centricity, security work across all these use cases here?
Well, I would just say I agree with you in summary. Like, that's all I could really say about it, is I completely agree with you. And it's the sort of a statement of common sense that I think, if you really care, like if you in the business of building a sovereign cloud, if you're a nation state, you're in the military business at the sharp end, you're in the spy business, intelligence community, something like that, there are times that you really have to care. Like, data is deadly at some level. And so that data-centric approach is key, but I also think that you can't displace responsibility. And so if you really need to know, you're not going to know by asking someone at Amazon or Azure whether or not their cloud is secure, because they're going to give you the security story. And it may or may not be true at some level, but if you really, really care, you have to own that. That's my fundamental belief. But I also believe that it's not schizophrenic for a sovereign owner of a cloud to use public cloud. I sort of said it a few questions back, but when cloud is good for you, it's perfect. Public cloud. And I think that there are cases where you want to consume infrastructure, and it's about the value of that data. And so again, we get back to comprehensive, but also enforcing consistent. So when you really care about that data, just run it on your own infrastructure. At least if you're going to put it in a public domain, you have to do something responsible with it, like encrypt it, which comes back to tools and policies. But I think it really comes down to the assurances that you want to embody in that data. And when you need a consumable, go and buy a consumable from a public utility. That's essentially how I see a public cloud. But I certainly wouldn't be in the business of taking something at the sharp end and deploying it into somewhere that I can't see it and absolutely know, like audit it to the nth degree. And I think what's really happening there is an injection of trust, which, in the irony of the overloaded term zero trust, what we're really doing is injecting trust. And I think there's a lot of convenience to displace that and inject trust in. And I think often not everyone is aware of the connotations of what actually happens inside a public cloud. When you've seen how that runs, you know just how many people can potentially have access to that data. And that also scares me. So I'll say that. And then, you mentioned AI. I think one of the things that AI is incredibly good at, obviously, is monitoring and spotting anomalies. And I think that we're just beginning down that path of using AI well to monitor particularly how data becomes transient and how it changes its disposition. So if it's moving from A to B, how does that look? How is it traveling? How typical is that? What do we know about the organism of the organization, the sovereign cloud, and how it operates normally? What is normal? What's policy? What are the mechanisms that we look at and then really make use of massive amounts of data, both for training, but also to wade through massive amounts of data in a really intelligent way? And AI is great at that. So I think that we're going to see a lot more of innovation there.
It's interesting you mentioned the fact that you're injecting trust, right? I always argued to people that were trying to federate zero trust policy enforcement point that all you're doing is really trusting someone else, PEP, and by definition you cannot do zero trust if you're just trusting someone else's decisions. And so what you see in the department, for example, is the Air Force, Navy, and Army and fourth is they building their own zero trust stuff in vacuums, but also even in one agency and one service they don't even have an enterprise service, so you're going to find program offices doing their own zero trust stuff in vacuum, so it's compounded to the nth factor. But so obviously if you just connect, just like you would federate identities, which you can do with identities pretty seamlessly today, and you compare that to federating zero trust policy enforcement point, obviously big difference there, because again the enforcement point is supposed to assess the risk, the user identity, the role of the user, the data access control, but then also the device used by the user and all these things, time of day, geofencing, and so on. Do you feel like blindly trusting another piece of the organization's PEP is by definition anti-pattern to zero trust?
Well, it's not comprehensive or consistent. The two C words fail right there, right from the get-go. I mean, it depends on the sort of level of competence and care, right? So I think trusting in general is a bad practice. I think you should be able to audit, and I sort of almost religiously believe in that, and it's embodied in virtually every member of staff in SoftIron that, we make a product that you should be able to audit, and we think that that's a place that's kind of got broken in industry. So I really believe in the idea that you should be able to audit and that trust should be as far out of the window as you possibly can have it. And when trust is necessarily inherited, you should be able to understand a security analysis of the potential downside of that trust, be that a piece of silicon, a piece of software, whatever it is. And so I would say it depends on the amount of care, but the idea that you do have to trust is the issue I have. It's not the outcome of a zero trust architecture. It's the fact someone's actually telling me that I have to do that. And I hate that, as a security paranoid, I hate someone saying, just trust me. And that's almost by default what the public cloud guys have to say to you is, trust me, I have TPMs, we have best practices, we do these things, we live up to these standards. But I really care about outcomes in security, not process. Process is your friend, that's good, but it's the outcome of security properties to me. And one of the things that happens around zero trust that I'll also say, not just the injection of trust and it's described as zero trust, what often happens is it becomes a mitigation philosophy. So the opposite of an outcome. You don't trust it, and so therefore you don't have to care about security outcomes. I think that that's a very broken downside of misconceptions around zero trust. And I think that that can be a very dangerous thing, particularly in a public cloud, because you don't know the consequences of data destruction. You don't know how many times data is replicated. You don't know where it really sits physically. You may know regions and you may be able to enforce that, but you don't really know where it is. And then all of those clouds are connected inherently, so data can be mobile. And where did it disappear to, should you be compromised or something go wrong? So I think this idea of being asked to trust is against my security paranoid religion. That's really all I've got to say.
Yeah, and it by definition goes, opposite to the term zero trust.
Right,
So
right. And if
yeah,
you have to trust, and we live in a world where sometimes that's necessary just out of practicality, you should at least in the
yeah,
data
there's
centric.
nothing that's zero trust anyway, so it doesn't
Yeah,
exist.
and you can try to get really hard, and I think you can do a good job, but again, nothing's perfect. And so when you do trust, I think with the data centric approach to security, you have to look at the cost of that. What is the potential downside? What is the value of the data? What does it really mean? What does it mean across a life cycle? And this is like the day one thing versus the day n thing, or day 2+ is, what happens to the life of that data? Because data is a living product, even if when it's immutable, it has a life of access through visibility. And I think this is another important conception that is often missed. It's just, you have to think about it as a life cycle.
Yeah, no doubt, no doubt. So, obviously we've seen the supply chain risk increasing, and people getting into source code, people getting into DevSecOps platform and build servers, people getting into dependencies used by many other software teams. So when you look at the impact of software supply chain risk and the management of it, what impact does it have on data centric security?
Well, I mean, supply chain risk is a big topic. It's massive. Actually, if you talk to certain people in the right places in government on the right days, you'll definitely realize that it's being exploited, kind of ever increasingly, actually. And it's a vector of attack that is kind of latently embedded. It doesn't even have to be exploited. It just has to be inserted. And that's what's really terrifying. It has a long-term persistent risk by definition. But often some of those vectors for attack can be very, very, very troubling, like national infrastructure, etc. And it's like talking about death sometimes, this topic. People want to talk about it partially. They don't want to talk about it fully, because there's really the perception that there's no answer to this problem. And I think there are answers to this problem. And I think you have to be incredibly diligent, though, to get through it. But it's not just software supply chain to me, it's hardware supply chain, and also, beyond that. And I think, often it's the supply chain risk to me is the tip of the iceberg, because if you buy a chip from Kenny, that's the hardware side, it's assembled by Wendy and you get software from Bob. You know where it comes from, you know how it got there. You don't necessarily know everything that it does, either from a hardware or embedded software firmware type attack, or another vector of attack with higher level software. And again, you sort of, if you don't do this right, you're injecting another form of trust. And that trust is a very wide spectrum. And I think the governments of the world and the people that really care about sovereignty have worked out that supply chain risk is a massive vector for attack. It's long-term, it's persistent, and it's terrifying in its magnitude. But for it to really have any kind of zero trust credibility, you have to tackle that entire spectrum. And that means you walk straight into both hardware, software, and also its design and its mechanism. Because the possibility of injecting things into a compute platform are very, very wide ranging if you don't control the entire spectrum and have the entire spectrum, frankly, auditable. That's what I believe. And again, I believe it as a security paranoid, because I don't believe I should be asking someone to trust me. I think that's exactly the wrong answer. So I sort of have a very fervent belief about that.
Yeah, but obviously the hardware and the software side compounded, one would seem to think it's almost impossible to, because it's exponential too, right? Because dependencies are dependencies are dependencies. How do you recommend people getting started on their understanding of the risk if they are starting tomorrow with no visibility on their supply chain today?
Well, we're having a nice chat here, and I don't want to turn this into an advert. But I work at a company where this paranoia, this sovereignty, this continuum of supply chain and design chain and that risk, we live that every day, and we try not to get people to say, we try not to say to people that you should trust us, and that we don't want to talk about death, or we don't want to talk about the full spectrum of supply chain risks, because they are real risks, and they are manifesting themselves in the real world. And so treating hardware as a piece of just hardware and then running anything on top of it without knowing what it is, that is trust, massive trust, or you might even say it's so massive it's a belief system. But people don't want to talk about it because I think they perceive there are very few options. And so you see in all sorts of really sensitive communities that their technique is to open up the boxes, inspect them, and count components and do things like that, which gives you some physical reassurance. But the real payload in there is often embedded firmware. And I think that's a thing that often is either neglected, felt to be impossible, or is not understood, which is if you look at a modern server today or a modern laptop or any kind of computer at all, there are so many pieces of software running independently that represent ways of compromising product that you can't even see. So, for example, compromising certain kinds of boot code, which has been done and seen in the field, you can get underneath the kernel, underneath ring 0. You actually can't see that you're being compromised. And that compromise may sit latent forever until it's needed. And, likewise, you see on servers with things like out-of-band management, BMC chips, that's a mini computer running its own Linux distribution or other operating system. And it has a direct path often to credentials, identities, authentication, and the ability to collect data that could be abused or compromise a machine is almost, it's hard to state how damaging that could be. And, this is often not discussed to its extent. We talk about where we get chips, how we assemble them, care and custody of that assembly through its life and its delivery. And then we inspect, which is a form of mitigation. It's a form of trust. And I think that is a thing that people are starting to work out gradually. I think particularly sovereign areas of government, intelligence communities, they're starting to work out that this is actually a real problem. And that's very promising to me.
Yeah, no doubt, no doubt. So, many people reach out to me and ask us about some of the lessons learned of building a government US, centric cloud. Many government in the UK, in France and Australia and so on, NATO partners, everybody is talking about building sovereign clouds, right? Trying to protect the data. And, I always tell people, well, look, we spent 10 billion with Amazon and we started there. And despite spending that kind of money, which most people don't have, we were not able to have parity between the government regions and the commercial regions. And so slowly but surely, we're 2 to 4 years behind in capabilities between the government regions and the commercial regions, which funny enough, when I move SH from the commercial fabric to the government fabric, there was a lot of cyber things we were using that didn't exist on the government region, which one would argue makes us less secure, trying to be secure, so defeating the point to begin with less security. And
Yep.
so, obviously, spending that kind of money is probably not sustainable anyways. If you look at some of the cloud providers with JWCC, right, between the Google of the world, the Amazon, the IBM, and so on, everybody's trying, and Azure and Microsoft, with Amazon and Amazon and AWS building, unclass secret, top secret regions. I know, you also need to keep up with a SAP enclave and so on. And so, it's almost unsustainable, but yet we kind of have the money, but, most governments don't. And then, we have the advantage of having the leader cloud providers based in the US, right? If you go to France and you're going to try to partner with OVH, they're already starting 20 years behind on the commercial side. So if you're gonna put their stuff on the government, French government side, it's gonna be 40 years behind, right? So I would argue sometimes that, hey, if the velocity matters to be able to compete, and if you need the best of breed solutions to compete, which one is more important? Sovereignty of the data, which you could achieve by other means with encryption and other things. In fact, the IC runs on dirty clouds at the edge every day and do it, securely, allegedly. So what's your take when it comes to dealing with those sovereign clouds? Is is it a fallacy to think we can even get there as a, for smaller teams and smaller governments? And is that the path to security, and data-centric security specifically, or can you achieve the same outcomes with different means?
There's a lot of irony. Like you said a lot of things just now, and to unpack some of those, you have two kinds of hyperscalers playing together and seeing it not work. One is a government with $10 billion. That's arguably a non-technical hyperscaler, as I would sort of call it. And then you have the famous hyperscalers, the public cloud providers. They get together and things don't work. And that's a very interesting thing. You also see that doing things outside of a hyperscaler at a small scale is a challenge if you try to do it the same way hyperscalers do it at scale. We also know that doesn't really work. And so, I think governments want sovereign clouds. They want them for sure. We're talking to a lot of them. And they also use public cloud in really sensitive applications. And I don't think either is actually fundamentally wrong. And it comes back to this option's a good thing. And the question to me is one of two things. You either absolutely need to know in the sense of trusting and control, or you want to consume infrastructure harder than you want to know, in which case you're going to inherit trust. And so there's a tension between those two things, but there's a business decision or security decision to be made. And I think those two things can complement each other. I mean, we're in our company in the business of on-premise infrastructure and hybrid clouds, sovereign clouds, etc. We do that every day, and that's our focus in productization. But I actually am a great believer in public cloud, and we at SoftIron use public cloud for certain things because when it's good, it's perfect. So there is a place for both. I think the question either or is the problem. I think it's ironic to me as technologists, we're ones and zeros people. And so we want to make a choice, it's one or the other. And the real world is always some analog value with a decimal place in it. It's this hybrid annealing that happens with all technology over time. And I think that's a beautiful thing if you embrace that sophistication in answer. If you just say that it's a hybrid and where you need to really know, you build a sovereign cloud and you can do that. My fundamental belief is you have to do that with a product. If you try to do what's happening inside a hyperscaler, not at scale, it's going to disassemble and you're not going to get the better properties. So you may as well go to a cloud you have to trust. I buy that argument, but I also buy that it's not impossible to make a sovereign cloud and embody it in a product, because that's what I just spent 10 years of my life doing. And I'm sort of viciously proud of the result. I really believe in the result. And I don't believe in it through any proprietary nature. I can demonstrate it. Like I can go and show you the guts. I can show you every single facet of that and say, this is how we embody security. This is how we make sure that we have FIPS 140-2 or -3. This is how we have, we got FedRAMP approval for this. We have these kinds of processes, these kinds of stacks. We do this kind of thing when we build the product every day in our CI/CD pipeline so that we always know the CVEs are immaculately up to date. So there are things that you can do. And then there are also things in productization that allow you not only to be able to audit every part of it, but also to have particular properties that are more radical than old-fashioned infrastructure. And I think the problem in building a sovereign cloud and keeping up with the progress of what you would have available in a commercial cloud or in a hyperscaler, but still have the auditability, the lack of zero trust goal, and not have to displace into that public resource, is you have to fix it with technology, and you can't do it like we've been doing it for 25 years. And that's sort of my raison d'etre. That's why I live every day. It's what I'm all about, and the whole company. And so I think often there's a spectrum between the grass is greener on the other side, or because they have hyperscaler properties, I'm going to displace certain beliefs about what actually happens behind the curtain. I think often people don't understand what actually happens in a public cloud around systems administration and other things that in the human domain that touch boxes. So whether it's a government, whether it's some sovereign area that really cares, I think The answer is that there's a place for both, but if you're going to do it at a small scale and you're going to really do it as a private or sovereign cloud, even in a hybrid arrangement, you need to really have the ability to not be told to trust it. I think that's the only reason that you would do it.
Yeah, I guess what's interesting is if you talk to a lot of nations, right? They would say, well, we don't really have the funding to build a cloud provider, obviously. The only reason why we don't want to use the a US based cloud provider is because of the Cloud Act and because of the law, and having fear that the data will end up in the US hands. And then they don't have enough money to build an alternative, and if they do, it will just end up being some basic data center with some virtualization and compute and storage, very far away from the capabilities of today, cloud providers in AI and Kubernetes and all the fancy services and SaaS and PaaS and so on, right? If you look at how much Microsoft or Amazon spend on innovation, it would be the entire budget of the nation, So, how do you see? So I guess is the fact that you want to protect your data a good reason enough to build a sovereign cloud, or is there a way to protect data in a dirty location, in a sense where effectively you don't trust the provider, but you still use it because it's the best of breed capability, and it's what enables you to move at the pace of relevance?
Yeah, I completely believe in that approach, and we've done arrangements exactly like that, where we have a private cloud that does certain things. We care about data. We care about that data a lot. And then at the point that you, for example, want offsite backup, you encrypt the daylights out of that thing with whatever techniques you think are appropriate, and then you push it to a public cloud where no one is capable of reading. I think that's one example, one instance, not the only one. There are hundreds. But that's one instance where public cloud is good for you. It's offsite. It's reasonably cheap enough. You're pushing data in. You're probably not pulling data out. So the economics are good for you, the sort of right ones, and just sort of leave it there. The data direction is right, usually for the fees. There are classes of storage that are really cold that are good for backup. So again, we're here, public cloud is good. It's nigh on perfect. It's offsite. It's elastic. It's scalable. It's well run in terms of high availability. And the security properties we've mitigated, we think, completely with encryption. So that would be a great way of running sovereign first and then using public utilities where public utilities are good. And again, that's generally a very easy thing to back out of and go somewhere else. And that's another key thing about sovereignty is represented in that property for me, is if you can't get out of somewhere, you're not very sovereign in the first place. So addressing public cloud in that way, I think, is the way it should be done. And to go back to, if you look at how much innovation Microsoft and Amazon and everyone spends and the things that they do, I think it would be a fair statement to say a government couldn't afford or keep up with a hyperscaler performing their own game, which naturally in information theory leads you to an assumption, which is, well, maybe we don't do the same thing as a hyperscaler, but do it ourselves. Maybe we do something else. And so maybe we don't take, switches from vendor one, computers from vendor 2 and 3, and storage from 3 or 4 vendors, jam them all together, knit them all together, orchestrate them, and have thousands of people running all over the place just to make it, a wonderfully run product, which they are. Maybe you need a different approach. And maybe that approach is that it needs to be embodied in a technology that by definition wants, by its first order assumptions, wants to be sovereign, wants to go from a fairly small scale, like very sub-rack, small footprint, to maybe a regional data center size. It wants to work with security properties, with public utilities, or maybe multiple clouds in your domain that do different things. It wants to have all of the nice things like Kubernetes, all the virtualization types, etc. But it knows on day one that everything in that cloud is meant to be in a cloud. It's never going to be a separate server, right? And so like the way we build clouds is from products that you couldn't use any other way. They have to be in a cloud. There are all of the consumables that compute and storage, you can buy them incrementally, you can plug them in. And there is literally no config file on that product when you buy it. And there never is when you unpower it and repower it. It's totally stateless. And so we see very much in the way we build clouds, properties that you would normally see in software stacks like Kubernetes, where things are stateless, they're amorphous, they're meant to boot and be part of a cluster by its mentality, as opposed to separate containers and software programs that have no way of being orchestrated in that way. And that's how a sovereign cloud has to be built outside of a hyperscaler. If you want to afford it, you want to sustain it, you want to be able to manage it with virtually no people, because skills in a classified environment in particular are becoming even more short, in supply. So those are the kinds of mentalities I think you have to approach the problem with. But what everyone says is, how do I build a cloud? And I think this is another thing that is a misconception of clouds and how cloud technology can help, as opposed to old server technology built in a cloud, which both achieve the same result day one. But day 2 to N, the living with the cloud is actually the thing you need to look at. And that's what makes it expensive. That's what makes it fragile. That's what will make all of the properties that you see in a hypercloud, in a hyperscaler, a wonderful outcome is they have an orchestration on a massive scale with massive budgets and massive numbers of people, and they're planning for success. And a government can't do that without technology first. It can't be an assembly project, because day 2 to N is what will kill you. You get it built, but then you're cursed. And that's why technology embodiment and productization is key. And that, we didn't come into this business knowing that. That's something that we developed over a very long period of time, watching customers do everything from storage, compute, clouds. And as you watch customers become unraveled, not through any fault of their own, just they're busy, they have a business to run. Their raison d'etre is not to run a storage array, for example, or a cloud. They want to use that cloud. They want to do exactly what a public cloud is there for. They want to consume it, but they need all these properties. They need security. They need, hopefully, auditability. They need high availability. They need scalability in the elastics and incremental sense. And they need that performance to scale. And it needs to just be a known property. And I believe in the fact that it should be a demonstrable property, that when you present the technology, you should be able to say why it's going to do that versus why a conventional approach to building a cloud at hyperscale is not right on a small scale, or particularly in a sovereign environment.
Yeah, that's so interesting. I think people already start to understand kind of the intricacies of building those hyperscaler and kind of coordinate the orchestration between all these environments and things, and enforce them and provide auditability and visibility across the organization. So something you mentioned to me in the past is this concept of auditable provenance. What is that, and why is it significant?
Well, provenance to me is a thing that I believe is a whole spectrum that encompasses everything that gets you to a zero trust outcome on a compute platform. So it's the fact that you can prove it, is provenance. And so when you say I can prove it, you better be true to your word, right? Or you're going to look really silly. And so the ability that you can audit any mechanism, or if you can't see a mechanism, you can do a security analysis of the threat level of that mechanism. If you can't do that, you have no comprehensive way of knowing how much trust you're injecting into something. And as a result, it's very hard often, not impossible, but very hard often to understand the threat level or the incumbent level of risk that you're inherently trusting into. And so, we spent the last decade basically going all the way through the design chain of everything that is made that's electronic in the company is designed by people that are employees at the company, and they're checked by others. And we often even arrange how we do those electronic designs specifically for security properties, or specifically for the ability to audit it, how we lay things out, how we design, etc. And then every single piece of firmware, boot code, software that runs on there is either a combination of open source that is inherently auditable and reproducible on a build by build basis, and is also forward and backwards chain compatible. So you can audit from the hex file or the binary that runs on a machine all the way back to source code, and from source code to the binary. And every piece of that code, every piece of embedded code is designed inside SoftIron or comes from open source. And we arrange all of those things together in a very, very unique way, so that, you know, someone who cares, really truly cares about sovereignty, can come into the audit center and they can do, you know, a drains up, sit with design engineers personally, and we can guide them through not only a security analysis, but every single piece of code. And I'll give you examples just to make it practical. You know, when most processors boot up these days, before you even see a boot prompt or a UEFI, it boots on the basis of firmware, and that firmware has access to internal peripherals in the chip you can't even get to in the kernel. So unbelievable amount of access and control over even security parameters related to RAM, training of various different peripherals that reach out on the board, like PCIe, etc. And then if that's compromised, that's a very big deal. So that's important, but often even invisible to technology people. They don't know that that really is there unless they're in the process of building motherboards. You might not ever know that. And then, you know, usually a processor boots into some kind of BIOS or UEFI, and if you can compromise that, you can be underneath the kernel, and you can have unbelievable control of whatever runs on the box. You can see everything. And then we have a mini computer on most servers that do out-of-band management, you know, the BMC, IPMI type flavor of things. And that's incredibly potent in its visibility over things, control of hardware, the ability in some cases to even destroy hardware, the ability to see credentials and watch everything that's happening on the machine, or control its performance or reliability. So there are things there that are incredibly toxic should it be compromised. And if you look at how most servers are built, they're assembled, they're not really designed, and there is no provenance in the design chain or any kind of repeatability. Often the chips that you see, the software you see changes even on the same stock keeping unit from day to day, from order to order. And so what you've got is constantly changing and certainly not auditable. And all of these are massive latent threats, long-term persistent threats that could be complete compromise. And that's the world we live in. You know, often a motherboard, just the motherboard, let alone the rest of the server, may come from 6 or 7 vendors between firmware, software, boot code, operating system, etc. And so the amount of trust that lives all the way from the top of the infrastructure, in our case, running high-level orchestration software, all the way down to chips and peripherals on the board, all of that has to be understood. And that mechanism should be visible if a customer wants to see it. And that's sort of a religious belief for me. And it is possible. It took 10 years, but it is possible to do that. And we do that across the whole spectrum of our products.
So what would you say is the cost of doing that versus, you know, financially having to do that? I mean, you know, in proportionally to not doing it, are you saying it's do you think it's a 2x cost of doing business? It's a 3x cost, 10x cost to do the same outcome without the trust, you know, between no trust and full validation, or rebuilding stuff in house or whatever, and just hoping for the best and, you know, wing it.
Oh, I mean, I think it's, unless you're going to embed provenance as a property of a product or a portfolio of products in our case, unless you set out as a technology vendor doing productization, it's almost impossible to achieve this outcome. So you have to audit the vendor or trust the vendor, which is a bad thing, but you can audit the vendor in our case. And unless you do that, it's almost impossible to go and do this development. And the cost to the customer is nothing. We sell at market price. We don't charge a premium for any of our products. We sell the products competitively against all comers, including the cheapest things you can see in China. And, you know, we don't see a cost disadvantage in the market. You know, we're very competitive. But the cost to SoftIron is tens and tens and tens of millions of dollars in 10 years. I'm proud of the result, but it was really painful to get here. I can't even begin to go into how unbelievably painful this journey was, and how hard it is to, for example, create firmware or UEFI or BMC stuff that doesn't lean on something else that requires trust. And to the extent that when we first started the company, we had no plan to, for example, make our own BMC. We bought BMC chips out of China. We bought software out of Taiwan, ran the software from Taiwan without source code on the chip. And, we got to the conclusion in the end that, ironically, as a small player, no one really wants to deal with you. You're not really making that much business compared to the really big guys. So at least when we started out, no one really had a sense of humor. And so often we were forced into doing these things. And then later we were speaking to a very senior general in the US military, and he said, look, what you've built here is amazing. It's completely and utterly unique. No one can say this, and we've looked really hard. And so all of the brand names that you would see on the high street selling everything from servers to laptops, they do the same thing we started out doing, which is they buy chips from here, software from there, firmware from there. And they are very focused on an outcome, which is often not even repeatable. It changes from day to day. They use different chips, different, controllers in PCIe slots, for example, depending on supply chain, particularly during COVID. So it's a world where we assemble computers for the effect that they run software. And then what it's actually doing, what the mechanism is capable of, what the threat is, or what you're really trusting is almost impossible to see unless you do it this way. But it has to come from the technology vendor.
Interesting. So, tell us a little bit about HyperCloud. You slipped and you said it before, because that's effectively what you guys ended up building. Tell us what is it?
So it's a way of building clouds, often sovereign or private or hybrid clouds from a technology. So by that, I do not mean a collection of technologies. So we made the HyperCloud technology, and consistently all of the components of a cloud are built from that one technology base. It's a set of mechanical designs that are consistent across all of the different boxes that you would use to build a cloud. It's one set of electronics with a high-speed backplane with modularity so that you can do different things, storage, networking, compute, acceleration, etc. But it all runs identical software in the form of firmware, source code, build pipeline, as well as, across all of the different functions, it runs one consistent binary. And that binary comes itself from the cloud. And so when we built HyperCloud, we took this very holistic, very, very different approach to building a technology platform we knew was only going to be clouds. And so the idea is to build a zero touch, as close to zero touch and zero integration fabric as we possibly could, and make all of the things like compute, storage, acceleration, complete consumables, like you would view containers in Kubernetes. They come, they go, they're self-organizing, self-orchestrating. They know they're part of a cloud. They just get on with being a cloud. And when you pull the power out and you put it back in, it's zero trust by definition. You can audit what the mechanism is by provenance, but it doesn't start with any assumptions. It doesn't even have a boot drive. So it boots and it looks for a cloud, and all of the state is kept in the cloud. And so they join that cloud, they naturally know what to do. And so you have a complete different day 2 to day N experience about just say, let's pick one thing, just continuous integration of different vendors with different version numbers that may or may not be compatible. We're running the same binary, so it's inherently compatible. It upgrades every single time you reboot it. That's your life cycle experience. It can reboot itself. The software can program the hardware can program the software. It really is a cloud technology. And I think, kind of the first of its kind that's gone this broad and holistic. We have lots of assets in technology. We have different forms of virtualization. We've had that now in commodity compute platforms for years, decades. We have different kinds of storage technologies, different kinds of networking technologies, but none of them really come out of the box and work together. And it's not just integration, it's life cycles of integration and compatibility and outcomes that look like consumable clouds. And let me just pick one, and I'll stop talking because I could talk about this all day long. You have these secondary properties that come out. So for example, if you build a cloud from, say, storage, networking, and compute, just to keep it simple, often when you buy storage, it comes with certain protocols, a certain version of that protocol, certain characteristics. And what you really want it to be is forget all of the details and the vegetable soup of technology. What I really care about when I consume a cloud is I have to be able to scale it incrementally. It has to be highly available. I never want to lose a single bit of data. We've never done that in the history of the company. I want to scale my performance as I scale my estate, and I want it to be massively scalable measured in exabytes. And then I want to consume it how storage was really supposed to be consumed all along, not through a conduit or a protocol or some iSCSI NFS or some other goofy protocol. I want it to be an inherent part of my virtualization environment. So when I run everything from, a Lambda to a VM and everything in between, Kubernetes estate, I want it to be at the bottom in a natural way that a computer can consume it, so that I don't have to live with that problem. And what I'm really saying, and this is painful for us every day, is SoftIron has to do that. HyperCloud has to do that. So you can see this pattern of we're paying for these properties that you get in a cloud, a public cloud, high availability, scalable performance, elasticity, all of that, and security. You're paying for all of these secondary properties by going an awful long way in productization so that it's completely consistent, completely comprehensive. The functions are keyholes often, conduits to storage. They look like drives or they look like whatever. They're consumed by the virtualization types, and you don't have to think about it. You don't have to run a storage estate. You just consume it, and it's SoftIron's job to make sure you can consume it on natural terms, as opposed to connect to protocols and do all these other things. But that's the mentality how people build estates. That's certainly how hyperclouds, hyperscalers have done it for years. But they have so much scale, so much talent, so much staff, and so much money that they can do it at an abstraction where you consume it. But the difference with hypercloud is the embodiment of hypercloud is consumable in its primary state before it's orchestrated, before it's stood up. And there is no integration. It just runs from one technology. And the approach is, I know it's very radical, but the success that we're having with customers is amazing. And it's not lost on them, but it's not lost particularly on people. The best business development for us is someone who's tried to build a cloud or tried to use virtualization and a bunch of other bits in a cloud, and they've got to day 2 to N, and then they understand what the pain really is in an estate. A hyperscaler doesn't pay billions of dollars or whatever in payroll to build a cloud or even continue to build a cloud. They have to sustain it, and that's what's hard, right? So that's the difference. That's the innovation that is in hypercloud. And a lot of properties like provenance with the lowest power servers, probably in the world in certain categories. And that's because we design everything in-house, and they're not generic computers, they're custom made. So often will be, say, 1/5 of the power you'd typically see from a commodity server in certain applications. And those numbers are measured. I'm referencing specific numbers. So there are lots of other properties that you get that when you run your own estate, you really care. You care about reliability. We have great figures on that because of the heat reduction, because of the power reduction. We design everything, and so we can make them custom for the task. And as a result of that, because of the whole chain, you get this provenance property. And so there are all these properties that actually look either better or as good as a hyperscaler when you want to run a sovereign cloud. But like I said right at the beginning, it has to be embodied in product or you just fail. You fail at scale, you fail to live with
it. That's pretty amazing. How big is a team now, I guess, to achieve such a feat?
We're a team that's about 100 wide. It's kind of an amazing team. It's certainly the best engineering team I've ever worked on, and I've worked with some really good ones. And an amazing statistic that I worked out the other day was, I think the reason the team has been so successful and productive is because a lot of us come from repeat offenses of working together and building hard things across lots of industry. Yeah. And I added up all of the previous years that people had worked together before any of them joined SoftIron to join the merry crew again. And across 100 people, we have 1,000 years of previous working experience, and a large swath of the company is brand new to everyone else in the company. So it's not just familiarity at some level that has built the team. It's just an amazingly deep team that have worked together for years. So super high bandwidth communication, very much a family feel, very unique compared to anything I've ever lived in or built before. it's a beautiful place. And it's been an incredibly hard journey to build this with purity, and it's the purity that, if you inject an if and or a but into a technology that's promising to do this, you just shattered everything, right? And so holding the line and doing that is a complete testament to the team. It's actually really humbling to be around.
Yeah, that's amazing. So what's next? What's the next big thing?
Oh, for us, I hope more hyperclouds, but I think the next big thing for us is I think everyone's talking about AI, and there are some amazing things going on there. But I think one of the things that is an unspotted technology pattern, I think not for many, but for some, particularly if you're a consumer of technology and you don't really care about it for its own sake. I think AI is described as a noun or a verb and a product in itself. And with things like ChatGPT, it kind of is, right? That's the kind of bells and whistles of the whole situation. But I think what will happen, aside from those things, is I think that AI is going to look like an iPhone would have done 20 years ago. You're holding a supercomputer in your hand. These smartphones are so amazing and so powerful and so pervasive in our lives. It's just amazing to be thinking about that just, decades ago. But I think maybe a decade from now, AI is going to be an adjective rather than a noun or a verb. And it's going to upgrade virtually every product that we touch at some level. And I think that's going to be the most pervasive adjective sense of, it's going to be the most pervasive effect that I think AI has in the world. And so I'm really optimistic about that. It's obviously something we take to heart inside SoftIron every day. And yeah, I think it still has a lot of promise to come.
Yeah, no doubt. I was gonna ask you what keeps you up at night.
Oh, this company called SoftIron. It's been doing it. I think I'm a decade of sleepless nights, and just the mission, right? Like what we're trying to build is very, very hard and radical, and it's taken a long time. And I want to continue to see it done right, because what we have is precious. It really is radical and different, and does these things that I think are amazing. But we have to hold the line, and so that is the thing that does keep me up at night, is can we continue to preserve the purity so that all of these promises are fulfilled, as opposed to diluted to a point that they then become academic because there's an exception case. All of the things I've been saying are pure in the sense that I'm saying them. And so that's the no ifs, ands, or buts sort of phrase for me. It's, it has to be right. And it has to fulfill these properties, these secondary properties that make it look like and consumable like a public cloud, but you can actually own it, audit it, see it, test it, pay a fixed price, use it to 100% utility 24 hours a day, and still, have your own cloud on your terms, on your own turf. And then also embrace public cloud, of course, as well. When, it's good, it's perfect sort of thing. And that's really that, and keeping up with technology. I find that sat in this chair and not in the CTO chair, the burden of keeping up with technology makes it look like it's moving incredibly fast again. And that leaves me to paranoia, because heaven forbid I'd trip up on that and then not be able to make the right calls to keep it right, to make sure the technology is pure. So those are the things that are sort of my obsessions after 8 o'clock at night.
Yep, no doubt. That's pretty much everybody's problem right now. The velocity of innovation is insane. So I get it. You're always afraid something is going to show up to completely disrupt everything, right? So well, first, wanted to thank you so much for the time. This was a great session. I think people now understand the different options they have to really build a sovereign cloud, and what to pay attention to, and they know who to talk to as well. We're gonna leave you with the last words in a minute. Before that, I wanted to remind everybody that the next episode will be on the June 30th, 13th, 1-3, at 1 p.m. And we're going to have Sam joining us from Cyber Advisors. He's a CEO of the company, and he's going to talk to us about cybers and try to help everybody when it comes to startups and businesses be able to apply and hopefully get some of these cyber funding phase 1, phase 2, phase 3s, and how to navigate that nightmare of paperwork and paperweight. to hopefully get to some money to improve your product so they can work with the DoD. Wanted to thank you again, Phil. That was great. Over
Well,
to you, I guess, for the last words.
yeah, I just would say if you're interested in what we do, reach out. We're friendly and house trained. We're nice guys. And I'd like to thank you, Nick. I think what you're doing here is really important. I think you bring a different lens and a credibility to what you talk about that is rare. And I'd really like to thank you for that. So thanks for having me on, Nick. I hope to see you again.
Thank you. We'll see each other soon, hopefully. And in the meantime, everybody, keep up the good fight so our kids have a fighting chance at winning against China 20 years from now. Stay safe, everybody. Thank you.